Hello, geometry students. This is Mr. Schussler. Today, we are going to be talking about 2- and 3-dimensional figures. This is our last lesson before we review for our summative project and exam. So just a heads up for that. Today's lesson objectives. First, we are going to identify and name polygons. We're also going to touch briefly on finding the perimeter, circumference, and area of 2D figures. And then we are going to move on to the second part of the lesson, which is to identify and name 3D figures. And then we will find the surface area and volume of that. Again, we're going to touch briefly on finding the surface area and volume. I would suggest a ruler would be helpful for taking notes today. I noticed some of you were not taking as thorough notes as you should have. You know who you are, so I suggest grabbing a ruler to help take more concise and neat notes. So go ahead and grab one of those. First, let's recall polygons. I touched briefly on them in our first or second lesson and what they are. Polygon is a closed figure formed by a finite number of coplanar segments. But these segments have to have a common endpoint that are not collinear. So for example, segment GM and HG have a common endpoint, but they are not collinear. And each side intersects exactly with two other sides at their endpoint. Two sides, two sides. This is why something like this is not a polygon, because there are more than two sides at this endpoint. So these are all polygons. These are not polygons. It's important that we understand how to name polygons. For example, we have concave and convex polygons. A convex polygon has no points of lines that are in the interior. They're all in the exterior. A concave polygon, on the other hand, has some points with lines that pass through the interior. See, for example, this line passes through the interior, and this line passes through the interior. So convex and concave, make sure those are in your notes. Naming polygons. So an equilateral polygon is a polygon in which all the sides are congruent, meaning they have the same length. An equal angular polygon is a polygon in which all the angles are congruent, the same measure. When combined, an equilateral polygon and an equiangular polygon create regular polygons. For example, this pentagon, all of the sides are the same length and all of the interior angles are the same. So we would call this a regular pentagon. A real-life example of a regular pentagon, I believe, is found in the United States. The Pentagon building is the United States Defense Department's headquarters. And it is this massive defense headquarters that the United States has. So you can search that up on your own if you want to see a regular pentagon in the form of a building. In terms of knowing these polygon names, in terms of the naming, triangle, you're all familiar with. A quadrilateral, a square or a rectangle is a quadrilateral. Pentagon is one you should know. And also octagon is a common one. You don't need to know all of these. You're not going to be asked on an exam what is a heptagon. As you work with them, though, you will get more familiar. So I would suggest writing down this as a reference so that you can quickly reference it if it comes up in a problem. Hexagon. Here's just an example of some regular polygons and some irregular polygons. So a equilateral triangle, a square, This is a pentagon. Here we have and an octagon, which looks awfully familiar. A regular octagon is a stop sign. And then irregular polygons. Angles that have equal angle, but not equal sides. So a rectangle, all of the angles are right angles, but the sides are not equal, so it is an irregular polygon. Next, we have sides that are equal, but the angles are not equal. So this parallelogram has equal sides, but the angles are not equal. And here we have sides that are neither equal nor the angles are equal. So they are considered irregular polygons. Now try in your notes, write these shapes down and classify them. So go ahead and stop the video. First we have 1A. We see that it is 4 sides, so it is a quadrilateral. We know that it is convex. And we know that it is irregular because 2 sides are the same, but then 2 other sides are different. So that is how we would name the first one. For B, this one could be named a decagon. If we count up all the sides, we get 10. So it is a decagon. This one is concave because we have lines here that go through the center. So it is concave. And it is also irregular. Because we have angles that are not the same. Last, we have a hexagon. This one is convex. Because we have angles that go outside, or lines that go outside. And it is regular. Because if we look at the symbols, they're all the same length or the same measure of it on the angles. So hopefully you got that in your notes. Again, I just wanted to briefly touch on perimeter, circumference, and area. As you can recall from previous math classes, I would suggest having quick access to this. So we have perimeter of a triangle is just adding up all the sides, A plus B plus, C, D, and B. The area, 1/2 base times height, height being the height there. A square, if it's all the same, it's just 4S, and the area would be S times S. Rectangle, again, adding up the sides, length, width, and the area is length times width. And you know a circle is 2 pi r, or 2 times the diameter is the circumference. The area is pi r squared. Now, we are going to move into the world of 3 dimensions. So we're going to add a dimension. We're going to talk about polyhedrons. A polyhedron is a solid with all flat surfaces that encloses a region or space. You will notice that the flat surfaces are called the face. They make up a plane. The edges are the intersection points of the face, and they make up lines or segments. And the vertex is where two lines or segments intersect, and that is represented by a point. So we can see the similarities between 2 and 3 dimensions. They have different names, but they coincide to similar properties. Now, 3D objects are classified into different types. So, for example, polyhedrons. A prism of a polyhedron is a polyhedron with two parallel congruent faces. So we have this congruent face and this congruent face, and it creates what we call a prism. A pyramid, on the other hand, is a polyhedron that has a polygonal, it's a hard word to say, polygonal base, and 3 or more triangular faces that meet at a common vertex. Next, let's look at what are not polyhedrons. So a cylinder. Even though a cylinder has 2 parallel congruent faces, we have the top and bottom, it is connected by a curved surface, so it is not a polyhedron. A cone is a solid with a circular base connected by a curved surface to a single vertex, so that's why it's not a pyramid, because it has this curved base. And a sphere is a set of points that are the same distance from a given point, whether that's the center of the sphere. A sphere also has no faces, no edges, or vertices. So how are they named? Polyhedrons are named by the shape of their bases. For example, we have a triangular prism. Notice that the parallel bases here and on the back side are triangular, so that's what creates the prism. A rectangular prism, on the other hand, has a rectangular base that are parallel, creating a rectangular prism. Pentagonal, 5-sided. Here we have a triangular pyramid, 3-sided base up to a vertex. And here we have a rectangular prism with a 4-sided base up to a vertex. Even a pentagonal prism, or pyramid, sorry, with the vertex at the top. So that is how you can identify and classify polyhedrons. Go ahead and try these in your notes. Are these polyhedrons? You will notice that this is not a polyhedron here. Here we have a cone. Even though it is upside down, it's still a cone. We have our vertex here and our circular base. That wasn't a very good circle. Anyway, this is a cone, so that means it is not a polyhedron. Here at 1B, we have a triangular prism. We see our base here. These are the 2 parallel faces, and they are triangular, so we have a triangular prism polyhedron. As you might expect, there are also regular polyhedrons and irregular polyhedrons. So if all of the faces are regular, congruent polygons, and all the edges are congruent, meaning they're the same length, we get what we call regular polyhedrons. A regular polyhedron, for example, is a cube, or a tetrahedron, which is a triangle, 4 equilateral triangular faces. So those are some examples of a regular polyhedron. And again, we're going to touch on surface area and volume briefly. I know you may have learned this previously in other classes, so I just want to spend a little bit of time on it. You will need to know how to calculate surface area, which is a 2-dimensional measure of a surface. Again, I would suggest copying these into your notes. You won't need to memorize these formulas, but you will need to be familiar with them and know how to use them. So the surface area and volume formulas, what each variable means, and where they can be found on a object. So for example, if I say this is a regular pyramid, the length is 7, the height is 8, the base is 5, you can go ahead and find either the surface area or the volume because you know how to calculate it. So just be comfortable and know how to calculate. We will talk about, or the practice problems will give you a little bit of practice in that, and so I wanted to just briefly touch on it and then let you practice it on your own. That's all I have for today's lesson. So go ahead and work on the practice problems. As I mentioned before, this is our last lesson of new content in this unit. So next class will be a review period, and then I will hand out our summative project. So be on the lookout for that, and I suggest that you start reviewing, especially all of the vocabulary that we've covered in this unit. Make sure that you have a good handle on it all. Thanks for watching. Enjoy your studies.